welcome to session 3 of Unit 2. In this session, we are going to talk about the equations of linear functions. We can recall or we can see that there is a session on this in basic mathematics. Now, much of our work in economics will involve relationships. For example, consumer expenditure increases as disposable income rises. This can be represented by a relationship or by a function that depicts a relationship. Now, quantity demanded on a good decrease as price increases, and so on. Such relationships can be expressed mathematically in the form of equations. In this very session, we are going to focus more on these equations that economics actually uses. And by the end of the session, we are believing that you should be able to distinguish between the three types of equation that we are going to use in economics. And you should also be able to identify various types of functions, types of what? Functions, all right? And you should also be able to derive the equation of a linear function. Derive the equation of a linear function. If you do not understand, do not worry. That is why we are here. Do not be scared. We are going to make sure that everything is broken down into smaller pieces for you to be able to understand. So let's get started with types of equations and then also functions. We treat these two as one. We look at the equations and then the functions as one. All right, equations and functions. In economic applications, we may distinguish between three types of equations. We are going to look at definitional equations, we are going to look at behavioral equations, and we are going to look at equilibrium equations. So let's look at the definitional equations. The definitional equation sets up an identity between two alternative expressions that have exactly the same meaning. As an example, total profit is defined as excess of total revenue over total cost. How do we get excess of total revenue over total cost? That is, we have to subtract total cost from total revenue. That is where we can see if there is an excess, and whereby that excess will depict what? Profit. How about behavioral equation? That one specifies the manner in which a variable behaves in response to change in another variable. In this case, we are trying to say that let's say this variable is dependent on that other variable. Let's take the cost function for example. Here we are saying C is equal to f of q. It means that the function C, it is expressed in what? The variable q. So the C will change as and when q changes. Or let's say the consumption function depending on the disposable income. So the consumption will change as and when our income, that is a y, changes. That is what we call the behavioral equation. We are talking about the manner in which a variable behaves in response to changes in other variables. How about equilibrium condition? Now, an equilibrium condition is an equation that describes the prerequisite attainment of equilibrium. So what is the requirement to attain equilibrium? In economics, when we say there is an equilibrium, we say that the quantity demand is equal to the quantity supply. So it has relevance only if our model involves the notion of equilibrium. Like I've said, in accounts, we say that quantity at equilibrium, particularly for demand and supply, at equilibrium, we say quantity demanded is equal to quantity supply, and that's what we call the equilibrium of a market model. Or you can say that savings is equal to what? Investment. Savings is equal to investment. When we are dealing with the macroeconomics, you are going to encounter that. So equilibrium of the national income model. National income model in its simplest form. All right. Now, if the relationship we have discussed here are systematic in the sense that a given value for one such variable always results in the same unique value for the other variable, we say that the variable is a function of the other. I repeat, if the relationship we have discussed are systematic in the sense that a given value for one variable always results in the same unique value variable, we see that the one variable is a function of the other. Hence, there is a functional relationship between them. Now, when we talk about functional relationship, we are talking about something like, say, y is equal to f of x. Y is equal to f of x. So we say that the functional relationship y equals f of x provides a rule by which we can transform x values into their corresponding y values. Now, functions can, of course, take many forms. Can, of course, take many forms. And for the moment, we shall consider constant function and polynomial functions. We are going to look at linear functions and quadratic functions. Now, the simplest form of function is linear function. This is a simplest form of function. Function is said to be linear if it takes the form I'm going to write below. So a linear function is of this form: f of x equal to mx plus c. This is the form for linear function. So it gives the functional relationship. This we can also say, or y is equal to mx plus c. Y is equal to mx plus c, where m and c are constants. M and c are constants. So m and c are constants. X is the variable. So for example, assume m is 3 and c is equal to 4. I can say that y will be equal to what? 3x plus what? 4. Then we have a linear relationship. Alright. Let's assume this is equation 1 and this is equation 2. So this relationship indicates that for every increase in 1 unit of x, y will increase by 3 units. This 3x is trying to say that the coefficient of x is 3. So anytime x increases by 1, y will increase by 3 times using a straight line. For this reason, equation 2 here, this equation 2, is referred to as equation of a straight line. No matter what the values of m and c are, the graph of equation 1, this equation, will be a straight line. The coefficient m in equation 1 tells us the slope or the gradient of the straight line. So in this case, when given an equation of this form and you're asked to find the slope, there's no need to go and find change in y over change in x. Even with this form, when you are going to find it, you are going to find the differentiation. Now, with normal differentiation, we see that first rule of differentiation, you say assume y is equal to ax exponent n. Then the y, the x will be equal to a times n, then x n minus 1. So now let's take for instance this one. Dy dx will be equal to, what is the coefficient of x here? The coefficient of x here is the exponent of x is 3. So we are going to multiply the 3 times the exponent, which was 1. Then we are going to subtract 1 from the exponent already, that is 1. Now this differential of a constant, that is the, so we can say plus 0. Now this gives me 3, then x exponent 0. Any number exponent 0 is 1, so I get 3. So instead of going through this long differentiation, what we are saying is for the linear function of this form, the coefficient of x is actually the slope. So when I ask you to find the coefficient or the slope of equation 2, you can tell me that the slope or the gradient is 3. That is the coefficient of x without going through this differentiation process. Now the m actually measures the change in y per unit change in what? X. And so that's why we say it is standing for the slope. Change in y per unit change in x. This is what the m in this equation 1 stands for. Alright. A positive value for m therefore implies a line sloping upwards from left to right. So assume now with this y equal to mx plus c, we see that the coefficient is positive. So we are going to have a positive slope. So if we are sketching a curve something like this, it will be like this. However, if I have an equation like minus mx plus c, it means that the curve is going to be downward sloping. So something like this. All right. So we are going to have a negative slope. Now the constant c in this constant c in mx plus c is the value of y when x is 0. So anytime x is 0 and this coefficient times the 0 give me 0. So when x is 0, y will be equal to c. Alright, so the constant c in y equal to mx plus c is the value of y when x is 0. It therefore indicates the point where the straight line intersects the y-axis. So when you are normally asked to find the intercept, you say, okay, when x is 0, what happens? When y is 0, what happens? So when x is 0, we get the, let me write on top of my board. When x is 0, we get the y-intercept. The y-intercept. And when y is equal to 0, we get the x-intercept. All right. Let me now clean my board. Then we will go to deriving equation of a linear function. It is possible to derive the equation of a linear function giving certain vital information about it. Such information could be 2 points through which it runs, or a slope, So we can either give you 2 points through which the line runs, or we can give you the slope and a point. We shall restrict ourselves to the former case, that is 2 points through which the line is given. When 2 points are given, when 2 points are provided, the formula we are going to talk about, the formula below, is used to derive the linear equation. Now, normally, we will give you something like y minus y1 equal to y2 minus y1 over minus x1 multiplied by x minus x1. Now, this can be written in a different way. I can write it as y minus y1 equal to m times x minus x1, whereby this thing we have here is the m. Remember, the slope, m is the slope or the gradient, is given by y2 minus y1 divided by x2 minus what? I can write this big formula in terms of y minus y1 equal to m minus what? M bracket open x minus x1. Now we'll try and solve some questions to understand this. Now, let's assume we want to find the equation of a straight line that passes through the point 5 minus 6 and 3 minus 2. We want to find this. How do we find it? Now, this will relate to x1, this will relate to y1, this will give you to x2, this will give you to what? This will give you to x2, this will give you to y2. Alright, so now let's try and write the equation. We have y minus y1 equal to y2 minus y1 over x2 minus x1, or multiplying x minus what? X1. Now I'll have y minus, what is my y1? My y1 is minus 6, so it will be y minus 6. Then I'll have here will be, what is the y2? Y2 is minus 2. Then minus y1. Y1 is minus 6, so minus 2 minus 6. Then x2 is 3. Then x1 is what? 5. I'll close this one. Then I'll have x minus x1, which is what? 5. Alright. Now here, minus will give me positive. So y minus minus, I'll have y plus 6. Then I'll have minus 2 minus 6. I'll have minus 2 plus 6. And I'll have 3 minus 5. Multiplying x minus 5. I have y plus 6 equal to minus 2 plus 6 gives me positive 4. Then 3 minus 5, I'll have minus 2 multiplying x minus 5. I would like to come and continue up here. I have y plus 6 giving me 4 divided by minus 2, I'll get minus 2 x minus 5. X minus 5. Then I can easily expand. When I expand this part, I'll get minus 2x. Minus 2x minus 2 times minus 5, I'll get positive 10. So I'll get y plus 6 equal to minus 2x plus 10. I want to make y the subject, so y will be equal to minus 2x plus 10. When the 6 crosses the equal sign becomes minus, so minus 6. I'll have y is equal to minus 2x plus 4 as my final answer. So this has helped me. The point they gave me only 5 and minus 6, and they also gave me 3 and what? Minus 2. And we have used these two different points to find the equation of the line that passes through these 2 points. We can similarly have been given, or we could have been given the gradient. Say they could have said that the gradient is minus 2, and they could have only given us only this point, and they will ask us to find the equation of the line. When that is the case, it is going to be also simple. How would that be? We know that y minus y1 is equal to mx minus what? X1. And that is how we are going to do it. Now, assuming we are given only this, we can say, okay, x1, and then let's say y1. All right, then we solve. We can have y minus the y1 is what? Minus 2, bracket open. What was the gradient? The gradient is minus 2. Now x minus, what is x1? 3. We can expand this part to have minus 2x. Minus 2 times minus 3, I'll get positive what? 6. Now here will give me y minus 2, I'll get y plus what? 2 equal to minus 2x plus 6. I want to make y the subject. It will be y equal to minus 2x, then plus 6 minus 2, because these two will cross to this part. Crossing the equal sign becomes what? Minus. This gives me minus 2x plus what? 4. And this is the same as we had here. So it's either they give us two different points, this and this, or they will give us the gradient and 1 point to find the equation, and we get the same thing. That brings us to the end of this session. Thank you.